Okay, so the first topic is all about sampling. That is section 1.1. And these are the objectives. So the first one, you learn how to construct a simple random sample, then determine when samples of convenience are acceptable, then describe the different other types of sampling, stratified, cluster, systematic, and voluntary response. And then the last part is distinguish between statistics and parameters. Okay, the first one, construct a simple random sample. So if you want to copy these definitions, I'll give you a minute about statistics, population, and sample. So statistics is the study of procedures for collecting, describing, and drawing conclusions from information. And this is what we're going to do for the whole semester. So you're going to collect the data and then describe, analyze the data with different graphs and use different statistical treatments. And then after you get the results, you're going to draw conclusions. And with the statistics, I'm sure you are familiar with like the surveys. Those are the most commonly used statistics. You're gonna need a population and a sample. A population is the entire collection of individuals about which information is sought, and a sample is a subset of a population containing the individuals that are actually observed. And since in the news lately about elections, like national elections, let's say for president, uh, we use a lot of statistics there, like for the surveys. I have a question. Why in uh, in any surveys, let's say who's uh, who's gonna win the presidency this coming November? So there's always statistics, and when you ask Americans, there's like 100 million registered voters. Uh, how much do you think of sample do we need to conduct a survey? Again, let's say we have 100 million registered voters, and if I own a company and I'm going to conduct a survey about who's going to win the presidency this November, what's going to be my sample out of 100 million?
1,000 people.
How many, Michael?
About 1,000.
1,000? Any other? Any other answers?
Is it percent based, like maybe 10%?
So you saying 10% is going to be uh, 10 million?
Perhaps, yeah.
Okay. Any other answers? Maybe I should ask all of you. Kami? Kami, just give me a number.
Probably, I'll go with 1,000,000.
1 million?
Yeah.
Antron?
Um, probably like, I don't know,
Just guess.
Okay, I'll guess like 2 million then.
2 million. All right, Anahi.
I'm sorry, I was noting when you asked the question, so could you please repeat it?
Yeah, okay. So let's say I'm going to conduct a survey about who's going to win a presidency this November, and I have 100 million registered voters. So how many respondents do I need to conduct a survey out of 100 million?
I feel like realistically we can do at least 100,000
100,000. Thank you,
to
Jasmine.
conduct.
Okay, sorry. Jasmine?
I say like 1 million.
1 million. Rebecca? Thank you.
Maybe like 10 million.
10 million. Michael?
I said 1,000.
All right. Chelsea? Thank you.
I said earlier 10%, so 10 million.
Oh, yeah, 10 million. Hosea? Hosea?
I would say 1,000.
1,000. Carlos?
10 million.
10 million. Anissa?
I would say 15 million.
50 million. Mary?
80 million.
Lily? Gina? You can also type if you want to.
Okay, I'm here. Yes, sir. Yes, for me, from my understanding, if the population is 100 million,
Mhm.
and you would like to have a sample of the registered voters, it depends on what your target sample will be to conduct the survey. So I think for me, if you want to know the registered number of voters, where you will get samples from, it depends what will be your target population, let's say per age or whatever bracket or category you might have to. I think for the numbers, it all depends on how many numbers you would like to have, maybe from 10 to 100 or 10 to 1 to 100 million, depends on what will be your sample will be.
All right. So thank you. So let's say the registered voters is 100 million. So what is good number? What's a good number of respondents that you need to conduct a survey?
I think I will be safe for 1,000 for now, just 1,000.
Okay, thank you. Kyla?
I would say perhaps 20 million.
20 million. All right. Thank you. Mary? Mary?
Yes. I would say the survey to be more effective, it should be more than the 50% of the population.
More than 50%. Thank you. Will?
20 million.
20 million. Amanda?
25 million.
2,500. Emily?
I say 10 million.
10 million. Derek?
15 million.
Michaela?
I'd say 50,000.
50,000. All right, thank you. Actually, those companies who are conducting a surveys about like this, a national survey, they only need actually like 1,000 or 2,000 or 2,500 or 3,000. So between 1,000 to 3,000. Why? Why do you think? Do you think that 3,000 or 2,000 gonna represent the whole country? Why is it valid? Why we can't use 50% or 10% or 5 million?
Do they vary the type of people enough to get a general consensus?
Yeah, they did. Yeah. Why do you think we cannot use 5 million or 10 million or
I just
500?
went based off of the fact that there's probably like 20 people from each state, like a jury.
But I'm waiting for one good.
Because it's a subset of a population.
Because of what? Sorry.
Because it's not gonna include the entire population. It's just a subset of a population.
Actually, it's gonna that 2,000 or 3,000, it's gonna represent the whole population. And all the surveys that you see on TV or newspaper, when you check, you will see that they always only use like between 2,000 to 3,000, and it's valid. It's always valid, and you'll learn later how to get those samples. So the reason why they don't use a big sample, number one is it's too expensive. So for any companies, that's number one reason, which is true. It's very expensive. If they want to release survey results every 2 weeks, then they won't be able to do that because number one, it's expensive. Number two, a lot of people, it's gonna take time for them to get the results, right? But they need immediate results. So take a note of that. That's why you need sampling methods how to conduct those surveys. Okay, thank you. So a simple random sample of size n is a sample chosen by a method in which each collection of n population items is equally likely to make up the sample. So you can do this by randomly. So you can to select your sample. That's the easiest. So let's say, for example, here, a simple random sample is analogous to a lottery. Always think that a simple random sample is a lottery. Suppose that 10,000 tickets are sold and 5 are drawn as the winning tickets. So each collection of 5 tickets can be formed is equally likely to comprise the group of 5 that is drawn. Okay, so let's check if the given example here is an SRS or a simple random sample. A physical education professor wants to study the physical fitness levels of 20,000 students enrolled at her university. She obtains a list of all 20,000 students numbered from 1 to 20,000 and uses a computer random number generator to generate 100 random integers between 1 and 20,000. Then invites the 100 students corresponding to those numbers to participate in the study. So is this a simple random sample? What do you think?
Yes, it is.
So Michael said yes, and that is correct. So this is a simple random sample since any group of 100 students would have been equally likely to have been chosen. Here, the professor used a computer to get those 100 students. Thank you. How about this? The professor in the last example now wants to draw a sample of 50 students to fill out a questionnaire about which sports they play. The professor's 10 a.m. class has 50 students. She uses the first 20 minutes of class to have the students fill out the questionnaire. Is this a simple random sample? Rebecca said no. Why not? That's correct. It's not an SRS because always remember that a simple random sample is like a lottery. So in which each student in a population has an equal chance. Here, the professor, he only got 50 students on his first class. He has different classes and he chose to get those 50 students from his first class. So he didn't give a chance, an equal chance, all of his students. So that's why this is not a simple random sample. Yep, students weren't selected randomly. So next one, a sample of convenience. If you want to copy this, in some cases it is difficult or impossible to draw a sample. And the best thing you can do is use some convenient method. And that's what we call a sample of convenience. A sample that is not drawn by a well-defined random method. And we have an example here. A construction engineer has just received a shipment of 1,000 concrete blocks. The blocks have been delivered in a large pile. The engineer wishes to investigate the crushing strength of the blocks by measuring the strengths in a sample of 10 blocks. Explain why it might be difficult to draw a simple random sample of blocks. So think again, you have a shipment of 1,000 concrete blocks and you need a 10 out of 1,000. So explain why it might be difficult to draw a simple random sample of blocks.
It would be pretty difficult to draw a random sample of blocks because if you did the lottery kind of method, like the university one, then you might have a block that you need to put for a sample that's under 3 other blocks and have to carry all of that weight. In general, from the looks of it, it looks like if you kept going farther and farther down each row and underneath piles of blocks, you'd tire yourself out so much just from getting random samples, so it would be difficult.
Yes, very good. Yeah. So yeah, you won't be able to use don't use to choose 10 randomly because it's going to be hard for you. Let's say if you chose 555, so you're gonna count where is number 555. It's gonna hard for you to get that block. So mostly you will just get the top on the top 10 blocks, right? So one way to draw would be to simply take 10 blocks off the top of the pile. So the problem with samples of convenience is that they may differ systematically in some way from the population. So always think this, that if it's reasonable to believe that no important systematic difference exists, then it is definitely acceptable to treat the sample of convenience as if it were a simple random sample. Okay, so that's the easiest sampling method. And there are other types. You're going to learn stratified, cluster, systematic, and voluntary response. So stratified sampling, if you need to copy that. The population is divided into groups called strata. Then a simple random sample is drawn from each stratum. So it is useful when the strata differ from one another, but the individuals within a stratum tend to be alike. So this is one way when I mentioned about when you use only like 1,000 or 2,000 to survey, use as respondents out of 100 million registered voters. So let's say you use different states, that's your different groups. And then let's say we have 50 states, and you divide, if you want to use, let's say 2,000, so you just divide it by 50, and then, or 51, and then you select those numbers within a state or within a group randomly. So that is stratified random sampling. An example here, so a company has 800 full-time and 200 part-time employees. So those are two groups, full-time and part-time. You have a population of 800 and 200. Then you're going to need to draw a sample of 100 employees. So let's say to get 100 employees, 10% for each. So that's 80 full-time employees and 20 part-time employees. So choose a simple random sample of 80 full-time and 20 part-time employees. So that is stratified random sampling. And the next one, cluster sampling. Items are drawn from the population in groups or clusters. Cluster sampling is useful when the population is too large and spread out for a simple random sampling to be feasible. So now what's the difference between this and stratified? So an example here, to estimate the unemployment rate, a government agency draws a simple random sample of households in a county. Someone visits each household and asks how many adults live in a household and how many of them are unemployed. What are the clusters and why is this a cluster sample? So if we go back to cluster, items are drawn from the population in groups or clusters.
Is it because they're done by county?
Say that again.
Is it because they're done by the county?
Done by
They're grouped together in counties.
Yeah. So what's the difference between stratified and cluster?
One is grouped.
And cluster?
Cluster is the one where it's grouped, right? It's drawn from a large population.
It's actually both.
Both of them are grouped.
Yes.
But one of them, the stratified is just taking like a simple random of the group, whereas the other one is taking the whole group.
Very
the
good.
cluster is taking the whole group to survey.
Yes, very good. Thank you, Kami. So did you hear that? So stratified is also in groups, but you have to use simple random sample for each group. While for cluster, there are different groups, and then out of those different groups, you use SRS to choose one group, and then you use that group. However, let's say if you have 1,000 respondents within that group, then you have to use the whole respondents within that one group. So that is a cluster sampling. Or let's say you choose two groups, then you have to use everyone within those two groups. That is a cluster. Okay. Next one, systematic. I'm going to show you more examples later. So systematic items are ordered and every Kate item is chosen to be included in the sample. This is one of the easiest. So an example here, automobiles are coming off an assembly line. It is decided to draw a systematic sample for a detailed check of the steering system. The starting point will be the third car, and then you're just gonna choose every fifth car after that will be sampled. So you start on the third car, then every fifth to get the next car. So based on this 30 cars, so you're gonna use as a sample the third car, the 8th, the 13th, the 18th, the 23rd, and the 28th. So that is systematic sampling. And the next one, voluntary response, are often used by the media to try to engage the audience. For example, a radio announcer will invite people to call the station to say what they think. And most often, voluntary response are biased, because people who volunteer an opinion tend to have a stronger opinions than it's typical of the population. And also people with negative opinions are often more likely to volunteer their response. And it always depends on their mood. When you do it, let's say from a radio announcer or online polls. Any questions so far about those different sampling methods? Okay, the last one, the last objective, distinguish between statistics and parameters. By the way, you will see this until the end of the chapter, so that's why this is very important, statistics and a parameter. So copy this. Statistics is a number that describes a sample, and a parameter that describes a population. And let's try to answer this. Which of the following is a statistic and which is a parameter? The first one, 50% of the teachers at Central High School are female. What is this 57%?
A parameter.
All right, so that is correct. A quantity, 57% is parameter because it describes a population, the entire population of teachers. You talk about the teachers here at Central High, you have 57% female. How about the second one? In a sample of 100 surgery patients who were given a new pain reliever, 78% of them reported significant pain relief. That's correct, Kyla. It is a statistic. When you write a statistic, not statistics. So the quantity 78% is a statistic because it describes a sample. Very good. So you will always see in a statement, look at this, in a sample of 100. So meaning you're talking about a sample here out of a population. So 78% of this sample, so meaning that is from a sample that is statistic. Okay. All right, so that is 1.1. If you go back to all these topics that we discussed, you should know what is statistics, difference between a population and sample, all the types of sampling. We started with the SRS, And then the other types, stratified cluster, systematic and voluntary response. And the last one, you describe the difference between a statistic and a parameter. And before we go to the next section, I'll show you, by the way, this is the ebook. So when you register, when you create your account for Connect Math, so on the top right here is an ebook. So you will always be able to use this. And when you click on the ebook, can you see my screen? So you'll see all the chapters here. And this is chapter 1. So 1.1. You can, this is exactly the same thing as the hard copy of the book. And also on the second tab here, the media, you will also see all the videos about each section or about the section for all the chapters here. So if you want to rewatch, if you want to watch how the author discuss those topics, you can do this. You can watch all these videos, okay? So here, let's try to answer some of the problems here. All right, since we just talk about statistics and or parameter, so let's answer 17, 18, 19, and 20. Who wants to read the problem and then answer? Let's start with 17.
I'll do it.
All right, thank you.
And sorry in advance for the noise you hear in the background. That's my daughter. Okay, number 17. In a recent poll, 57% of the respondents supported a school bond issue. That would be a statistic because it was taken from a poll instead of like a fact from a general statement.
Right. All right, next one, 18.
Oh wait, are you asking another person or me again?
Oh no, the next one.
Okay.
Volunteer. Thank you, Michaela. Next volunteer, number 18. Read and try to answer it.
I'll do it.
Yeah.
18, the average age of the employees in a certain company is 35 years.
Mm-hmm.
And I guess that would be parameters.
Yes, thank you. Next one, 19.
Of the students, so can I go ahead? Thank you.
Yeah.
Of the students enrolled in a certain college, 80% are full-time. Parameter.
That's correct. So you're talking about all students, and 80% of those are full-time, so that's correct, a parameter. Next one, 20. Volunteer, 20.
I'll do it. 20. In a survey of 500 high school students, 60% of them said that they intended to go to college. And I want to say that is a statistic.
All right. Thank you. That is correct. So take a look at this. In a survey or in a recent poll, so meaning you do that you get a sample out of a population. So you talk about a sample statistic here because that is from a sample. Very good. Okay, next one. Let's try, since it's a lot, let's try some of the problems here. Identify the kind of sample, whether it is simple random sample or stratified cluster, systematic or convenience. Okay, number 25. Who wants to read number 25 and answer?
Ladies and gentlemen, I'd like to make an announcement. There is no need to continue tonight.
Who wants to read number 25?
I'll read it.
All right.
So a college faculty consists of 400 men and 250 women. The college administration wants to draw a sample of 65 faculty members to ask their opinion about a new parking fee. They draw a simple random sample of 40 men and another simple random sample of 25 women. So would that be the stratified?
Yes. Very good, because you have two groups, men and women, and you get like 10% for each group. So that's why you got that 65 and 40. Thank you. How about who wants number 28? Read 28 and try to answer.
I'll read it. It's
Yeah.
police. Oh, go ahead.
You're good. You can do it.
Okay. Police at a sobriety checkpoint pull over every 5th car to determine whether the driver is sober. And I'd say that's systematic sampling.
Yes, so that is every 5th car is systematic. Thank you. How about 29? Tell us your opinion.
I can do it.
Yeah.
29. Tell us your opinion. A television newscaster invites viewers to tweet their opinions on a proposed bill on immigration policy. More than 50,000 people express their opinions in this way. Is it voluntary response sample?
Yes, very good. And how about a reading program? Anyone? Volunteer, number 30.
I'll do it. I got it.
All right, Carlos.
Reading program. The superintendent of a large school district wants to test the effectiveness of a new program designed to improve reading skills among elementary school children. There are 30 elementary schools in the district. The superintendent chooses a simple random sample of 5 schools and institutes the new reading program in those schools. A total of 4,700 children attend those 5 schools. Is that a simple random sample?
No.
No.
But thank you.
Yeah.
Who has another answer?
Would it be a cluster one?
Marky, why?
Because it's taking only 5 schools out of the 30.
Yeah. Yes, very good. So this is a good example of a cluster. So it's arranged in 30 groups, so that's 30 different schools. And then out of 30, you use SRS, you choose 5. And then everyone within those 5 schools, there's a total of 4,700 children, and you use those 4,700. So that is a cluster sampling. Okay. Next one, 31. Last one. Who wants to read 31?
I can do it.
All right.
Customer survey. All the customers who entered a store on a particular day were given a survey to fill out concerning their opinions of the service at the store. Would this be a voluntary response?
Is it?
Wouldn't it be a sample of convenience?
Yes, it's a sample of convenience. So you just you, survey everyone who's entering the store. So that is a sample of convenience. Okay. So there are other statements here, problems. If I were you, if you have time, try to use your ebook and answer those problems. And if you have any questions, you can ask me anytime. Okay. So let's continue our lecture. 1.2, types of data. So we have 4 objectives here. Understand the structure of a typical data set. And then you're gonna distinguish between the 2 variables, qualitative and quantitative. And then qualitative has 2 different variables, ordinal and nominal. Then quantitative has, again, 2 sets of variables. Those are discrete and continuous. So the structure, you start with the data, and then I mentioned you're going to have 2 variables, the qualitative and quantitative. And then you're going to take the information that is collected on those individuals. And then the information collected is called the data set. So first, qualitative and quantitative variables. Copy this. Qualitative classify individuals into categories, and quantitative tell how much or how many of something there is. Let's have an example here. So which of the following variables are qualitative and which are quantitative? A person's age, what do you think? Is it qualitative or quantitative?
Quantitative.
Very good. Person's gender?
Qualitative.
Qualitative. Mileage of a car?
Quantitative.
Quantitative. And the color of a car?
Qualitative.
Qualitative.
Sorry.
So if you're talking about numbers, that that is quantitative, and if you're talking about categories, that is qualitative. Okay. And then I mentioned, so again, you have variables. You have qualitative quantitative. And qualitative, there are two, either ordinal or nominal. And quantitative, there are also two types, that is discrete or continuous. Okay, so qualitative, ordinal, and nominal. Ordinal have a natural ordering, and nominal to not have natural ordering. So examples here, let's classify this, which of the following variables are ordinal and which are nominal. State of residence.
Is it nominal?
Nominal because there is, you don't write the states in order. Gender.
Would it be nominal?
Very good. So because also you don't arrange in order the gender, right? How about the next one? Letter grade in a class.
It would be ordinal because grades are based off of best to worst.
Yes, very good. So it's ordinal because it's arranged in best to worst, A, B, C, D, and F. And how about the last one, size of a soft drink ordered at a fast food restaurant?
Would still be ordinal because it has small, medium, and large.
Very good. Yes. So because the sizes are small, medium, or large, or extra large. Very good. And the last one, distinguish between discrete and continuous. So discrete, possible values can be listed, and continuous, it can take any value in some interval. So think about discrete. If you can count it, or if it's countable, then it is discrete. If it's not, if you can change the unit and you can have a different number of values, then it is continuous. Okay. Let's try these problems. Which of the following variables are discrete and which are continuous? Age of a person at his or her last birthday.
Discrete.
So yes, you can count the age of a person. That's why it is a discrete. How about height of a person?
Continuous.
Continuous, yes. Because you can measure the height in inches, or you can use a different unit. You can use in feet, or you can use a meter, right, for height. So you can, if you can use different units, then you will have different numbers, and that is continuous. How about number of siblings?
Would it be discrete? Because you can only count them a certain way.
Yeah, that's correct. So you can count the number of your siblings, so that's why it is discrete. And the very last one, distance a person commutes to work.
Continuous.
So yes, you talk about the distance, so it's continuous because you can measure a distance by either by using miles or kilometers or meters, right? So if you can use different units, so that's going to be continuous. And that's it for 1.2. You learn about data sets, and you should know how to distinguish between qualitative and quantitative, ordinal and nominal, and discrete and continuous variables. And before we end this class, let's have a quick review from the ebook. So here I go to the next section, which is 1.2, and we have enough time. So how about let's start with number 15. So describe either qualitative or quantitative. Volunteers, read and answer.
Okay, number 15, your best friend's name would be qualitative.
Thank you. That's correct.
Number 16, your best friend's age is quantitative.
That's correct. Next.
Number 17, the number of touchdowns in a football game will be quantitative.
That's correct. You talk about the number. Next, 18.
The title of your statistics book, it will be qualitative.
Yes, very good. Next.
I'll run a computer, that's going to be quantitative.
That's correct. Next. Right. Derek said 20 is qualitative. Is that correct?
No.
Waist size. What's your waist size? So meaning you're
It's a
talking
number, so it got to be quantitative.
about quantitative. Yeah. Okay. 21.
The ingredients in a recipe would be qualitative.
Qualitative. 22. No problem.
School colors would be qualitative.
Yeah, that's correct. Next one.
The makes of cars sold by a particular car dealer, that would be qualitative.
Yes, and the last one.
The number of cars sold by a car dealer last month will be quantitative.
That's correct. Very good. Next one, let's nominal or ordinal. Wants to read and answer. So the question is it in order or not?
Um, 25, the category strongly disagree, disagree, neutral, agree, and strongly agree on a survey would be ordinal.
That's correct. Very good. At 26.
The names of the counties in the state, those would be nominal.
Yes. Next one.
The shirt sizes of small, medium, large, and extra large would be ordinal.
Ordinal. Yes. 28. (28)
28, I got an A in statistics, a B in biology, and C's in history and English. That would be ordinal. Excuse me, ordinal.
Yeah, that's correct. Next one, 29.
Mm.
29. This semester I am taking statistics, biology, history, English. That would be nominal. Excuse me.
All right, that's also Derek's answer, and that is correct. Terry?
I ordered a pizza with pepperoni, mushrooms, olives, and onions. Would that be nominal?
That's correct. 31.
In the track meet I completed in the high jump and the pole vault, that's nominal.
Yes, very good. And 32.
I finished first in the high jump and third in the pole vault. Would that be ordinal?
Ordinal. Very good. Because of the first and the third. All right, last set. So this time either discrete or continuous. So remember, discrete is if it's countable. Once to read number 33.
Yeah. 33. The amount of caffeine in a cup of Starbucks coffee. That's countable, so it would be discrete.
Is it countable?
Yeah, I mean, it's countable for it's counted on the thing for you.
How do you measure the amount of caffeine in a cup?
I think what it's trying to say is you can measure it in grams or ounce maybe, so it could be continuous.
Yes, it is. That's why it is continuous.
Okay.
Okay.
All right.
All right. About 34.
34, the distance from a student's home to his school. That would be continuous because you can measure in miles, feet, anything like that.
Yeah, that's correct. Thank you. 35.
The number of steps in a stairway. Would that be discrete?
Yes. That's correct. 36.
The number of students enrolled at a college, would that be discrete?
Yes. That's correct. 37.
The amount of charge left in the battery of a cell phone would be continuous.
All right, that's correct. Next.
Mind explaining why the battery one is continuous?
All right, why is it continuous? Number 37.
You can count it as a percentage, or you can count it in time, or you can count it
in decimal.
Wow.
Yeah.
Oh, awesome. Thank you.
All right, 38.
The number of patients who reported that a new drug had reduced their pain, and that would be discrete.
Yes. 39.
The number of electrical outlets in a coffee shop, discrete.
That's correct. And the last one.
The time it takes for a text message to be delivered, continuous.
Very good. All right. Any questions?